So let me start with something that actually captures this perfectly. In 1977, there was an astronomer named Jerry Ayman who was working on something called SETI, the search for extraterrestrial intelligence. He was looking through computer printouts of radio signals from space, and he found something extraordinary. The signal was so clear, so unusual compared to everything around it, that he circled it on the paper and wrote "wow" in red pen, and the signal became known as the wow signal. Now here's what was beautiful about it. The signal was about 30 times stronger than the background noise. 30, that's enormous. It was in a particular frequency, 1420 megahertz, which is special because hydrogen, the most abundant element in the universe, naturally emits radio waves at this frequency. If you were an intelligent civilization trying to communicate with someone out there, this is exactly where you'd send your message. This was the obvious choice for saying hello. But here's the thing about science that I really love. It's not enough to see something once. You need to see it again. You need to be able to replicate it. You need to ask, can we check this? So they looked for the wow signal 50 times after finding it. 50 times, and they never saw it again. Not once. This is where it gets interesting, because now you have to ask yourself, what was it? And this is where most people went wrong. They fell in love with the idea. The idea was so wonderful that we had received a message from another civilization out there in space that they wanted it to be true. And when you want something to be true badly enough, you start interpreting everything in the way that makes it true. You find reasons to explain why it only appeared once. Maybe they only sent it once. Maybe their technology was intermittent. Maybe they were trying to be subtle. But that's not really how science works. In science, you have to be suspicious of your own hopes. You have to look at what actually happened and ask, what's the simplest explanation? And in 1994, Jerry Ayman himself, the man who discovered it, said something remarkable. He said, "We should have seen it again when we looked for it 50 times. Something suggests it was an Earth source signal that simply got reflected off a piece of space debris. In other words, maybe someone on Earth sent out a radio signal, a radio transmitter, a television station, a military installation, and it bounced off some junk orbiting above us and came down looking like it came from space." Now, he later backed off from this idea a little bit because the math got complicated. If it really was a reflection, the reflecting object in space would need to be just the right size, just the right position, moving at just the right speed. It's possible, but it's not the simplest explanation. But here's what's important. We still don't know what the wow signal was. And that's okay. Not everything gets solved. Some mysteries remain. The point is, we can't just assume it was what we wanted it to be. Now let me tell you about something more recent that's even more interesting because it actually shows how our thinking has changed. In 2007, scientists discovered something called fast radio bursts. These are very brief, very intense radio pulses coming from deep space. They last only a few milliseconds, but they pack an enormous amount of energy. And when they first found them, you know what happened? The same thing. People got excited. Some scientists, including a fellow named Avi Loeb, a physicist at Harvard, started saying, these could be artificial. These could be signals from advanced civilizations. Maybe they're the exhausts from alien spacecraft, or maybe they're beams they're using to push cargo around space. All sorts of exciting ideas. And it's not crazy to wonder. The universe is vast. We found billions of galaxies, and we know chemistry works the same everywhere. We know intelligence is possible because we're here. So why couldn't there be other intelligent beings out there? But here's what scientists at MIT did. They took a detailed look at one particular fast radio burst called FRB 2022-1022A, and they asked a very simple question. What causes something like this? What in the natural universe has the power to produce a signal like this? And they found something beautiful. Near neutron stars, these are collapsed stellar cores so dense that a teaspoon of material would weigh 1 billion tons. There are magnetic fields so intense that atoms can't even exist. The atoms get torn apart by the magnetic force. But these magnetic fields store enormous amounts of energy. And what they discovered is that these magnetic fields twist and reconfigure in such a way that they release energy as radio waves. And those radio waves are so powerful we can detect them from the other side of the universe. So instead of needing alien technology, you just need physics. Physics you already understand. Physics we already know about. The universe itself is capable of producing these things without any help from intelligent beings. Now, this is the moment where scientists realize something important. We were looking at signals from neutron stars and black holes, the most extreme objects in the universe. We were looking at physics at its limit. And here's the beautiful part. We learned something about the fundamental nature of the universe. We didn't find aliens, but we found something else. We found that we were bumping up against the edge of what the universe can do. But I want to tell you about something different now, because not all of these signals are from space. Some of them are from Earth. For decades now, there's been a project called SETI Home. It started in 1999, and it's one of the largest citizen science projects in history. Millions of people, literally millions, agreed to let their computers analyze data from radio telescopes. They were looking for anything unusual, anything that didn't fit the natural patterns. The data came from something called the Arecibo Observatory in Puerto Rico, a massive radio telescope that's now collapsed sadly, but it did extraordinary work. By the end, about 2 million people participated. And you know what they found? They collected about 100 candidate signals. 100 out of billions and billions of data points. Signals that looked unusual. Signals that didn't immediately look like natural sources. But here's the thing about signals. Your radio telescope doesn't only pick up signals from space, it also picks up signals from Earth, television stations, radio transmitters, military installations, cell phones. All of this is radio noise. And sometimes this noise can look strange. Sometimes interference from different sources combines in weird ways. So when you find a signal that's unusual, you have to ask, is it coming from space or is it coming from Earth? This is actually harder than you'd think, because the universe is also generating radio noise. Pulsars are sending out pulses. Stars are emitting radiation. Cold hydrogen is emitting radiation. There's radio noise everywhere. So you have to ask, what's the source? And it turns out that almost all of those 100 candidate signals turned out to be radio frequency interference. That's the polite term for noise from Earth. TV stations, radio towers, that sort of thing. Now someone might say, well, that's disappointing. We spent all this time and money and we found nothing. But I think that's the wrong way to look at it, because what they did do is they established a sensitivity limit. They said, if there's a signal from an extraterrestrial civilization that's above a certain power level and it's coming from the northern sky, because that's where the telescope was pointing, we would have found it. We would have seen it. That's not nothing. That's actually important information. That's a real scientific result. But now I want to tell you about something different. In 2023, something happened that was absolutely beautiful, because it wasn't a discovery of an alien signal. It was the opposite. It was a simulation, a test. An artist named Daniela De Paulus worked with scientists at the European Space Agency, the SETI Institute, and the Green Bank Observatory, and they created a project called A Sign in Space. Here's what they did. They used a spacecraft orbiting Mars, the ExoMars Trace Gas Orbiter, to broadcast a signal back to Earth, an artificial signal, a signal designed to look like it came from an alien civilization. And they sent it out. And multiple telescopes on Earth picked it up, and then they released all the raw data to the internet and said, okay, citizen scientists, try to figure out what this message is. Now this is beautiful because it's designed to answer a question that nobody can really answer any other way. If we actually received a message from an alien civilization, how would we know? How would we extract it from the noise? How would we decode it? How would we figure out what it means? So they had thousands of citizen scientists working on it, scientists from all over the world, different backgrounds, different expertise, and it took them almost a year, but two people, a father and daughter named Ken and Kelly Chaffin, they cracked it. They figured out the message, and the message was beautiful. It was an image of 5 amino acids. Amino acids are the building blocks of life. Life as we know it is made from these things. So the message was saying something profound about chemistry and biology and the origin of life. Now here's what's interesting about this. Even after they decoded the message, people argued about what it meant, different interpretations. Someone saw it as panspermia, the idea that life spreads throughout the universe. Someone else saw it as the building blocks of chemistry coming together to form life. Another person interpreted it in a completely different way. And this tells you something important about communication. Even with the best effort, even with the actual message in your hands, humans from different cultures and backgrounds struggle to agree on meaning. Imagine how much harder it would be if that message really came from another civilization, from biology, and thinking that evolved under completely different conditions. But let me come back to something more fundamental, because I think there's a human tendency that I want to talk about. We want to find something. We want the universe to be full of life. We want there to be other beings out there. And because we want it so badly, we sometimes convince ourselves that we see it when it's not really there. This happened with Mars, by the way. In the late 1800s, an Italian astronomer named Giovanni Schiaparelli was looking at Mars through his telescope, and he saw lines on the surface. He called them canals, channels. And then another astronomer, Percival Lowell, became convinced that these were not natural formations. These were built by an intelligent civilization. He thought Martians had constructed a vast system of canals to transport water. It all seemed to make sense. It fit together beautifully. But then we sent spacecraft. We landed rovers. We took close-up photographs, and you know what we found? Those canals didn't exist. They were optical illusions. The human eye, looking at grainy images at low resolution, was seeing patterns that weren't really there. The brain was filling in the details. This is called pareidolia, and it happens to all of us. Your brain is designed to recognize patterns. That's useful most of the time. It helps you survive. But it also makes you see things that aren't there. You see faces in clouds. You see animals in ink blots. You see meaningful patterns in random noise. And that's okay as long as you're aware of it, as long as you check yourself. This is why science is important. Science is a method to get around our own biases. You make a guess, an hypothesis. Then you design an experiment to test it. Then you look at the data without your biases. You ask others to check your work. This is why that wow signal is interesting to me. Because the person who found it, Jerry Eman, he had the integrity to question his own finding. He could have just said, "This is it. We found aliens." He could have published a paper and written a book and given talks for the rest of his life. But instead he said, "Wait, I need to think about this more carefully. I need to look at alternatives." And that's real science. Now, I want to ask you a question. We've spent decades looking for signals from alien civilizations. We've looked at the WOW signal. We've analyzed fast radio bursts. We've run massive citizen science projects, and we found nothing. Does that mean there's no one out there? This is actually a profound question, and it's called the Fermi paradox. An Italian physicist named Enrico Fermi asked it simply, if the universe is full of intelligent life, where are they? Where are all the aliens? We should see evidence of them by now. And there are various answers. Maybe life is rarer than we think. Maybe intelligent life requires conditions that are harder to achieve than we realize. Maybe civilizations don't last very long. They destroy themselves before they can spread throughout space. Maybe communication across the vast distances is just too hard. Maybe they're out there, but they're not broadcasting radio signals. Maybe they're using technology we don't recognize. Maybe they're hiding. Or maybe we're wrong about what we're looking for. We're looking for radio signals at a frequency used by hydrogen. We're looking for narrow band transmissions. But what if they're broadcasting on a completely different frequency? What if they're using laser light? What if they're doing something we haven't even imagined? This is the fun part about science. When you don't find something, you learn about your own assumptions. You learn about the limitations of your instruments. You learn about the universe. And here's something I think is really important. Even if we never find a signal from an alien civilization, the search itself has value because we've learned about how to detect and analyze signals. We've learned about how to distinguish natural phenomena from artificial ones. We've learned about physics, about pulsars and neutron stars and fast radio bursts. We've learned about how to organize massive citizen science projects. These are not wasted efforts. This is how science works. You look for something, maybe you find it, maybe you don't. But you learn things along the way. Now let me tell you something about why this matters philosophically. When we look for alien signals, what we're really asking is, are we alone? This is one of the deepest questions humans can ask. And whether we find aliens or not, the question tells us something about ourselves. The fact that we search means we believe it's possible. We believe that somewhere out there, chemistry arranged itself in just the right way to create consciousness. Consciousness capable of building radios and sending messages. That's a remarkable belief. It's optimistic. It says something about how we see our place in the universe. But here's the tricky part. We have to be careful not to let that belief cloud our judgment. We have to look at the data honestly. We have to consider alternative explanations. We have to be willing to be wrong, because that's what happens when you find a signal that looks interesting. Your first thought is aliens, but your second thought should be, what else could this be? Could it be a satellite? Could it be radio interference? Could it be a pulsar? Could it be our own equipment malfunctioning? You have to ask all these questions. And I think the people who do this work, the SETI researchers, the astronomers analyzing fast radio bursts, the citizen scientists on Discord channels trying to decode messages from Mars, I think they're doing something beautiful. They're asking one of the most profound questions we can ask, and they're doing it carefully. They're doing it honestly. They're willing to be disappointed because the truth matters more than getting the answer they want. So here's where we are. We've looked at signals from space, and we've found that the universe is more interesting than we thought. We've found collapsed stars that can produce radio bursts from across the universe. We've found that our own atmosphere and equipment can create interference that looks like alien signals. We've found that human brains see patterns even when they're not there. And we haven't found any confirmed signals from an intelligent alien civilization, not yet, maybe not ever. But that doesn't mean the search is pointless, because the search is actually about more than just finding aliens. It's about learning how to observe the universe carefully. It's about developing the tools and methods we'll need if we ever do find something. Let me tell you what I find most beautiful about all this. It's not the hope of finding aliens. Well, it's partly that, but mostly it's the process. It's how scientists approach a mystery. Someone finds something unusual, they get excited, but then they ask, is this real or is it an artifact? Is this what we think it is, or could it be something else? And they design experiments to figure it out. This is the essence of science. Not the answers, the questions, not the certainty, the doubt, the careful, humble process of trying to understand reality by looking at it honestly. So the next time someone tells you they think they found an alien signal, I want you to ask, have they looked for alternative explanations? Have they tried to reproduce it? Have they checked for Earth-based sources? Have they been honest about the limitations of their data? Because that's what real science is. It's not about getting the answer you want. It's about getting the truth, even if it's disappointing. And sometimes the truth is that the universe is even stranger and more wonderful than we imagine. Sometimes the truth is that we still don't know. And sometimes the truth is that we got fooled by our own hopes. And that's okay. That's science. That's how we learn.